Okay, we've got 3 bars, each made of A36 steel, 450 cross-section. I want to find the normal stretch in each bar given this loading. Okay, so the first thing again, I'm going to do statics here, and I'm going to draw the free body diagram right on here just to conserve some space. And I'm going to call this force D, this force E, and this force F. And these are basically the forces that go through each of those rods. And then what I'm going to do is I'm going to do statics. I'm going to sum the forces in the y direction, where I've got D plus E plus F minus 50 minus 80 equals 0. Then I'm going to sum the moments, and I'm going to sum the moments about that midpoint E. Okay, so then that'll give me 2 times F minus 2 times D, okay, plus 1 times 50 minus 1 times 80 equals 0. So those are my two equilibrium equations, my statics equations I gotta use. Simplifying those a little bit, I get D plus E plus F equals 130,000. Now I'm switching, I guess, from 50 to 50,000. I probably should have written that the first time, but those were in newtons. Those were in kilonewtons. Now they're in newtons. Okay, and then doing the second equation, I get 2F minus 2D equals 30,000. So I have two equations here, right? Equation 1, equation 2. However, I've got 3 unknowns that I've got to deal with. Okay, so I need now to do some sort of continuity equation. Okay, so what's going to happen here is there's more weight, or there's more load on the right side. So basically what's going to happen is, if I think about it like this, let me kind of redraw it here. There's where it starts at. The whole thing is going to basically move down some amount, but then it's also going to angle at some amount like this. I hope that makes sense. Okay, so this whole thing right here is the deflection of F, right? This guy right here is the deflection of point D. And then this guy right in the center here is the deflection of point E, right? So that's how it's going to deflect. It's going to move down and tilt a little bit, okay? Because again, there's more force over on the right side, so it should tilt like that, okay? So I'm going to use this idea to help figure this out. And what I know, okay, because E is right in the middle, because this is a straight line, what I know is this has to be 2 times bigger than this. Okay, so 2 times delta E, delta E minus delta D has to equals delta F minus delta D. Okay, so again, that continuity is what we're using there. Again, that little guy in the middle moves down twice as far as that guy on the right side, just based on kind of similar triangles there and the fact that it's right in the middle of that. Okay, so the other thing that I know is that delta, of course, is PL over EA. Well, these are all starting at the same length. They're all the same cross-sectional area, and they're all made out of steel. Okay, so essentially, these guys are all the same. The only thing that differs with all these deltas is the force going through them. So I can essentially rewrite this guy as 2 times the force at E minus the force at D equals the force at F minus the force at D, like so. And again, because the L over EAs are all the same, I can divide through and get rid of all of them. Okay? Now, mathematically, going through and saying, okay, let's simplify this a little bit. I get 2E minus F equals D. Now that's a third equation with these three unknowns. Okay? And I get the first two equations from statics, get the last equation from the elongation of the rods. Okay? And knowing the relationship between them. Okay? Now it's just three equations and three unknowns. Okay? So I'm going to shortcut through, assume you can do algebra and solve these, and I get D equals 35,833. E equals 43333, and F equals 50833. And again, I get that. Just three equations, three unknowns will solve that for me. Okay? Now that I have those, I can find the stress in each one of these, right? So the stress in D is just going to be 35833 divided by 450 square millimeters. So that's actually 450 times 10 to the minus 6. Because I want to get that in meters from millimeters. And from that, I get that the answer is 9.6 megapascals. Same thing for E, and I just get 43333 all over the area, 450 times 10 to the minus 6. And I get that one 96.3. And rather than writing it down, I'll just say, okay, F is going to be 5833 over the 450, and I get, for that one, 113 megapascals. So again, with these problems, start with statics. This time with statics, I got two equations, three unknowns. So I needed another equation. That equation comes from compatibility equation. That would be, again, everything elongates, but then it tilts so that the middle stretch is twice as much as the stretch at the end. Okay, from that picture there, again, using similar triangles. Then recognizing that they all start with the same length, the same modulus, the same area. Basically, all those can just be changed from deltas into their forces. That gives me my third equation. Find the force in each one. Force divided by area gives me the